Hi everyone, today I'm going to present my coursework in the analog and digital electronics tool. First, I will introduce about what is filter. The electronic filters works by First, I will introduce what is filter. The electronic filters work by rejecting signals by attenuating the unwanted parts and emphasizing certain frequency of the signal. On the figure on the slide, there are many different types of electronic filters which can be classified according to the frequency range they allow to pass. First is the low pass filter, which only allow low frequency signal to pass from 0 Hz to the set cutoff frequency. Second will be the high pass filter, which only high frequency signals are allowed to pass. Third will be the band pass filter, allowed signals falling with a certain frequency range to pass. The last one will be the band reject filter, which reject signals of a specific range of frequency and allow the rest to pass. In the above figure, the input signal amplitude is constant and the frequency is increasing from low to high. When the input signal passes through different types of filter, the output response will behave differently, and it can be concluded that the filter will pass the signal when the input signal frequency is within the filter pass band. In contrast, when the input signal frequency is within the filter stop band, the filter is being to attenuate the signal. So for our coursework, we choose to use low pass filter, and we need to determine whether you're using passive or active filter. The difference between both filters is active filter contain active components such as transistor and operational amplifier, while passive filter only using passive components such as resistor, capacitor, and inductor. Filter cutoff frequency due to changes in the load impedance. Therefore, under the influence of load impedance changes, the characteristics of the active filters are relatively more stable than passive filter. So we choose to use active low pass filter, and the circuit connection are simply connecting an inverting or non-inverting amplifier to the output of an RC low pass filter circuit as shown in the figure above. Due to the characteristic of the capacitor reactance is inversely proportional to the frequency of the input signal, therefore, at low frequency of the input signal, the capacitor is seen as an open circuit, while at high frequency, the capacitor is seen as a short circuit. Because of this characteristic, the combination of RC circuit will form a low-pass filter with a formula of cutoff frequency Fc equals to 1 over 2 pi RC. Therefore, any signal frequency above this cutoff frequency point is called the filter stop band, and any signal frequency before this cutoff frequency point is called as the filter pass band. Therefore, to obtain the 1 kHz cutoff frequency point, the capacitor value need to be 0.1 microfarad, and the resistor value after calculated using the formula will be 1591 ohm. For this design, the magnitude of the voltage gain is A max equals to 1 plus R2 or R3. And for non-inverting amplifier, the gain for this design is 2, which means when the input signal is 3 volt, then the output voltage will be 6 volt. The overall circuit design is shown in the figure above, and by adding some value inside. Next will be the simulation result. In the table above shows 3 different frequency of input signal and obtain different output voltage. For example, the gain in dB when 50 Hz input signal frequency is 6.02. When the input frequency is 1 kHz, which is the cutoff frequency point, the gain in dB will be minus 3 dB from the initial gain become 3.027. and after the input frequency more than the cutoff frequency point, the gain in dB start to become negative. This result can be easily shown by the frequency response graph, which shown on the slide. And for a low pass filter, the frequency response will show the gain will decrease slowly until reach the cutoff frequency point. After this point, the gain will start decrease with a roll-off rate minus 20 dB per decades. The potentiometer is very important in practical case because it can control the cutoff frequency of the low pass filter, and it has high precision of resistor value and can be adjusted. So we use a potentiometer at the low pass filter site. For the practical case, the frequency response was slightly different from the simulation. As the circuit designed just using first order low pass filter, so the effect not so obvious. In conclusion, the main objective of this coursework is to implement the design of a low-pass filter to pass only 0 Hz to 1 kHz signal. By changing the value of the resistor and capacitor, the cutoff frequency point of the low-pass filter can be changed accordingly.